Hi, everyone. Welcome. I'm going to give it another couple seconds just as everybody jumps on. But thanks everyone for coming today. Numbers are jumping fast. This is exciting. Okay. Well, like I said, thanks everyone for coming today. My name's Julianne Berg, and I am part of the VMUG team. So I would like to just welcome you to today's webcast titled, Why is VCF the Best Platform to Run VMs and Containers, Part 1. So today is really going to be an overview, and then next week we will have a deeper dive into this topic. And so I'm actually going to put the registration link for next week's as well. So if you want to take a deeper dive into this, you can register for that as well. Just a couple of quick housekeeping items to go over before we introduce our speakers. First, we are going to be recording today's webinar, and it will be available for you on demand on the VMUG website. So when I send I'll send an email after with that link so you can watch it again. Second, there will be a Q&A session at the end of the presentation today. So if you do have a question for our speakers, please put it in the Q&A box. Sometimes it's a little difficult for the speakers to follow the chat. So Q&A is a place where they can kind of organize all the questions together. And then third, there's going to be a short survey that pops up after the webinar. If you could just answer those couple questions and let us know what you thought about today's session, that would be great. We'd also love to hear from you what other topics you'd like to hear from us on these webcasts so we can put together a great program moving forward. So without further ado, I'm going to introduce Michael Roy from Broadcom's VCF team to start us out. Hey, Michael, we can't hear you.
Well, it helps if I unmute, doesn't it?
All right, there
Thank
you
you.
go.
Thank
You're
you for
back.
that. Hardware mutes, man. Oh, goodness me. So anyway, as I was just saying, with animation, hope everybody's having a happy Tuesday. Thanks everybody for joining us here today. As mentioned, my name is Michael Roy. I am your guide into the VCF division, aka VMware by Broadcom. So here today with another installment of our ongoing series of webcasts, continuing our mission to help the community of admins, aka folks like yourselves, in every way that we can be successful with VCF and all this really awesome new technology, all this new VMware technology coming from Broadcom. So today, we're going to talk about one of my favorite topics, containers and the platforms who love them, specifically two platforms. I'm, of course, speaking of VCF and Kubernetes. Um, we've often called VCF a platform of platforms. You can use it to orchestrate and run workloads of basically any kind. But there was a time where Canadians, the Canadian in me, were containers with a capital C, were a little less than first-class citizens. But those days are well behind us because, of course, VCF includes a native Kubernetes runtime, dial tone, we like to call it, baked directly into the platform. So we use Kubernetes not actually only to run containers, we actually use it to run and maintain and manage Kubernetes itself in a model that we effectively call the supervisor. So Kubernetes, it's everywhere these days, right? It's almost invisible. It's boring. I remember when the Kubernetes project started, we'd go to the contributor summits, and I remember our goal was to make it boring, make it behind the scenes. And I feel like we're finally at that level because it just works, it just runs, and organizations everywhere are using it to not only run apps and get open source and commercial off the shelf stuff, but they're also building and running these apps on top of this platform because it's incredibly extensible. And VCF is the single platform, of course, for containers and VMs, and it's got this new built-in VMware Kubernetes service. It's a CNCF's Cloud Native Compute Foundation certified upstream conformant Kubernetes runtime. So it's not like some fork or flavor of Kubernetes. This is Kubernetes, right from the source. And so this allows organizations to run modern containerized applications alongside all of your traditional VMs, all on the same infrastructure. You got VMs, you got containers, they're just apps, right? Workloads. So in this session, we're going to take a look at how easy it can be to run modern and traditional workloads side by side, and how you can enable your cloud admin teams and platform teams to collaborate a lot better using this new surface area. So this is actually a two-part set that we've got here today. So today we're going to go pretty high level, and then we've left some room for some demo near the end, but next Tuesday we'll have a very, very deep session on this topic. And again, the rabbit hole goes super deep on this one. So, but the net result here is that you end up with a platform that can be used to run whatever workload you need. Commercial off the shelf, custom homegrown, standalone containers, or even things that directly integrate with Kubernetes itself, custom objects, things like that. So all of this gives you the benefits of running on top of the VMware Cloud Foundation infrastructure. vMotion's still happening. You're still using the infrastructure you know and love. And so again, there's just so much to cover here. We've taken our time, and we're going to spread this out into 2 webcasts. So for today, we're going to go over high level, but again, like I said, we left some room at the end for a demo. And so to that end, we're joined by our 2 presenters from my product team here. We've got Audrey Bien and Katarina Brookfield from our product teams. And we're going to go over things in more detail. So today, we're going to be listening from Audrey at first. She's a principal product marketing manager here at Broadcom. Congratulations on the principal title. It's a big deal here. And so she's actually focused on Kubernetes in VMware Cloud Foundation. She specializes in messaging, but product positioning and the go-to-market strategy and execution. And basically, it's helping drive awareness and an adoption of the modern application infrastructure across enterprise environments everywhere. So she's going to kick us off today, and then Katarina is going to join us a little throughout the little closer to the end, and we'll have a demo and go into a little bit more deep dive. But think of it more of a teaser in anticipation for what you're going to see next week. Now that being said, we've got a Q&A box there. We've got a chat box there. I'm going to be backstage paying attention to both of those things, trying to answer and address things as we can. But by all means, if you have a question, please use the Q&A box. That does a little ping for us and lets us know that there's a question to be asked. We might get to them in real time. If we can answer them over chat, we may hang on to them. Most likely, we're going to hang on to them until the end, and we'll address everything, before we wrap up. So with that, Audrey, do you want to come on up to the front of the stage and kick us off?
Hello,
All right.
everyone. My name is Audrey Bien, and
All yours.
waiting in the backstage is the most nervous time for me. But anyway, I'm very glad to be here. It is my first VMUG session. And first, let me share my screen. So today we'll talk about the VMware Cloud Foundation. That's the best platform for running VMs in the containers. Now let's get started. First, let's take a quick look on the agenda. Like Michael said, today it will be high level. We'll make it interesting and storytelling. We give you a whole concept of why VCF is the best platform for all the workloads. We start with some industry trends, and we will talk about customer challenges and the personas in VCF. We'll give an overview of the VCF, the product as a whole, and we'll introduce to our Kubernetes runtime vSphere Kubernetes service. And we talk about why running Kubernetes in VCF is better on bare metal. Last, I will share some customer success stories. Then I will hand over to Katarina for a quick demo. Now let's start with some stats. They are exciting numbers. As we look at this current state of enterprise infrastructure, there are 3 key data point out and telling a compelling story. The first is the 97% of organizations, they are already running data-intensive workloads on Kubernetes. This highlights how mainstream Kubernetes has already become for critical high-performance use cases. The second is the 95% of the global organizations, they are expected to running containerized application. So this is a signal that it means like a massive shift towards cloud native architectures. And finally, 75% of the organization, they are committed to adopt Kubernetes for their future infrastructure needs. So what this shows is that Kubernetes is no longer just an option, it's a backbone of modern application infrastructure. So enterprises, they are moving faster to modernize. And the question now is not if, but it's how quickly they can scale and they can adopt Kubernetes in a secure, efficient, and enterprise-ready way. So now let's take a look how Broadcom contributes to this Kubernetes community. So Broadcom is proud to be one of the top 3 contributors to Kubernetes CNCF community. So much of our work began through VMware, which we originated several widely adopted Kubernetes projects, such as Vero, Contour, Harbor. And these projects are critical building blocks and are used across the cloud-native ecosystem. We've also supported a foundational effort like Cluster API, etcd, and we continue actively to the controller runtime, which is unpin a lot of many Kubernetes operators like today. So beyond the code, Broadcom is also committed to Kubernetes advocacy and thought leadership. We sponsor both CNCF and the Linux Foundation, participated in 6 special interest groups, and we engage regularly at the KubeCon. So we had our presence at the KubeCon in April in Europe, UK, and we will participate in the one in the US in November in Atlanta, I believe. So we participate through these expert-led sessions and community sponsorship. So, but we are not slowing down. Our ongoing commitment also include contributing to upstream Kubernetes, supporting certified Kubernetes distributions, and we directly build a Kubernetes runtime into our VCF. Now our goal is to ensure our customers that benefit from the innovations that's not only enterprise ready, but also our community driven. So as organizations start modernizing their applications, they are running into a set of challenges as well. So first, infrastructure complexity and silos. You possibly hear about that because it's difficult for teams to run VMs and containers on the same platform. The second is skill gap. So companies, they need to hire a special experts to running containerized workloads, especially for companies we see the data before they already adopt the Kubernetes technologies. So they need people to run these applications. The third part is security and compliance. I remember I've seen some data a couple of weeks ago. There's a survey. Customer, they responded to it. Their biggest challenge is the concern about security because they struggle to enforce, a consistent policies across diverse environments. So then there's the issue of scalability as well. Many platforms, they don't scale very easy or require complex manual work to do so. And finally, everything leads to higher cost. It's not just in terms of the infrastructure spend, but also in operational efficiency and the delay time to market. So these challenges are exactly why organizations, they are seeking for a more mature, unified, automated, secure platform to run modern applications at scale. Before we start diving into our product, I want to mention some personas in our VCF, and I hope you can keep this in mind because in the next few slides, we will talk about our product and link back to these personas. The first are the business leaders. So their primary concern about is cost efficiency, innovation, and security. These are really key to the company. And the second persona we've seen are the cloud admins. So they are more focused on operational efficiencies. They're concerned about security as well and governance. So basically, they need to ensure that SLAs are met and maintain a high availability and security. The policy, governance, and control mechanisms helped it to manage the compliance and reduce the risk. Also standardize the configurations and eliminating silos improve the consistency. Last is a quality service management ensure they deliver a smooth, reliable cloud experience for users. And we also have platform engineers. They are really key to our VCF. So they want a self-service access to the cloud services. They also want upstream conformant Kubernetes with the latest innovation. Also, of course, like security patching and compliance, they are very essential for them to maintain a secure platform. And now let's keep them in mind and let's dive into the VCF platform. So this is where VMware Cloud Foundation come in because VCF is a unified platform that bring together both VMs and containers on a single infrastructure. So at this core, we can see it automates and simplified operations across like storage, networking, and compute. As you all know, this is vSphere, vSAN, and SXT. And SX, sorry, not SST anymore. So on top of that, we have this modern cloud interface, which provides a centralized way to manage and operate both containers and traditional VMs. So this allowed our cloud admins to build, deploy, and operate. Also, at the same time, our platform engineers and the developers, they can consume the resources through a self-service manner. So what makes VCF so powerful is it's not just the infrastructure platform, it's integrated with advanced services like we can see on the top, like private AI, disaster recovery, load balancing, container operations. And these means organizations, they can securely run their applications at a scale and also at the same time maintain a governance, performance, and agility they all care. So our goal is for VCF to reduce the complexity. We want to eliminate the silos and it gives team a single platform to modernize infrastructure without needing to re-architecture everything from scratch. Also, we want to eliminate the cost for the companies to hire new talents. So we've just seen how VCF unified the infrastructure for both VMs and containers. Now let's take a quick close look on how this platform delivers even more value through built-in Kubernetes capabilities and cloud services. So first, modern applications, they require not just the infrastructure, that's a lot of people think, but actually they need integrated services and simplified access to development platform. So that's exactly what VCF delivers through our built-in Kubernetes runtime and a rich set of supervisor services. As we can see, again, in the foundation, it's the vSphere supervisor. It's a layer that connects with core compute, storage, and networking. On top of that, we have vSphere Kubernetes service. That's the key topic of today. We call VKS, which bring the native Kubernetes capabilities into the platform. So allow our customers and the users to run containers side by side with VMs. What's really make the differentiate VCF is the layer of the out-of-box cloud services, which is available through our supervisor. So first is we can see on the top layer is the multi-cloud cluster management automation service mesh, which will be new to the VCF, and identity access control. These are streamlined operations and the security. And the second level is our VM, network service, storage backup, and image registries. This provide developers and our platform engineers with everything they need to support production workloads and right out of the box. So this unified stack support a wide range of workloads from analytics, AI, ML to business and time critical applications. And remember the personas we mentioned earlier? Let's take a look how they're gonna do in this diagram. First, for developers, they will get the seamless access to the services they need without worrying about the infrastructure. And the platform engineers, they can provide secure, reliable environment at scale. And for the cloud elements, they retain the control, which is so important, and the visibility required for all the operations. So with VCF, with the supervisor, the teams, they can spend less time stitching together the infrastructure and more time delivering their innovations. So as I mentioned earlier, VKS is a key topic. Let's take a look on some highlights of our VCF Kubernetes service. First is a unified platform from a single API. So a single platform which offering one API is having the benefit of provisioning and managing both VMs and containers through the same way, and simplifies the infrastructure management. And the second, we have the self-service access and governance. It provides self-service to the infrastructure services. So platform engineers, they can deploy resources while also sticking to the governance policies. And we also give our users a choice of different interfaces, such as cloud admins. They no longer need to manually write the YAML files, so they can leverage a GUI to configure Kubernetes clusters that auto generates YAML file. The benefit is that it prevents these misconfigurations and provides an easy overview of settings before deployment. Like I mentioned, the same API, which enables our infrastructure as a code, and the platform engineers, they can handle large scale deployment without human intervention. And the CLI enables our platform engineers to automate workloads deployment and make sure it's a faster execution compared to the UI-based workflows. And for Kubernetes itself, we offer the upstream conformant Kubernetes versions, which is like aligned with the latest innovation, and our users, they can upgrade independently from vSphere. At the same time, we give our users and like the personas in VCF the flexibility of when they want to upgrade their Kubernetes versions. So customers, they can also deploy previous N-2 Kubernetes versions. This flexibility enables agility and a control over Kubernetes environment. Customers, they can keep their own pace when it comes to workload modernization. And what's coming soon is our long-term support as one of our coming features, which will be very similar to hyperscalers. And so in February this year, we announced the VKS 3.3, and the next month on the 17th, which is June 17th, we're going to announce the VKS 3.4. So there are some like key features I want to mention here. First is to support the latest VKR versions. And the second, it enhances security with the FIPS mode. So basically, during the creation of the VKS clusters, FIPS mode can be turned on and off. It's usually required by the industry like government, finance, healthcare, public sectors. So when FIPS mode is enabled, it encrypt method will help organizations to meet compliance regulations and reduce the cybersecurity risks. Also, we improved the easy integration of the Windows Kubernetes workloads. This enhancement, basically, we simplified the integration of Windows-based workloads into Kubernetes clusters by reducing manual work and ensure the consistency. Because Windows nodes, they are properly authenticated, and it reduces unauthorized access risks. And the last one is also very important, is in this new release, we removed no scaling from 0 or to 0 limitation for auto scaler for clusters, and support like automatically scaling Kubernetes clusters down to 0 or when it's not used. This is really important for applications like seasonal applications or workloads there with fluctuating demands. So it helps our organizations and customers to save their cost. Now on this diagram, we can see in the bottom, the dark blue lines is our virtualization platform, and the light blue is our Kubernetes runtime and orchestrations with IS. Now let's take a look what's in the Kubernetes standard packages. As we mentioned, we have cluster, autoscaler, contour, harbor. These are all packed together in the standard Kubernetes packages in VCF. And what's new here is we also integrated a data services management into the Kubernetes runtime orchestration layer. Basically, it streamlined the data service lifecycle management, and a beautiful VCF, it enables a scalable data service deployment with efficiency and security. The last is a support like a MySQL and a partner object store. So this is also new. So we will add multi-cluster management into VCF as well. So previously it's the Tanzu Mission Control TMC. We will provide the fleet-wide multi-cluster management, out-of-box baseline security policy, and also Kubernetes label selectors for backup and restoring clusters, namespace, and a group of resources. That's gonna coming soon. So I have been talking about all the amazing things about running Kubernetes in VCF, but I guess you might have some questions in mind. Or you might have heard like, hey, running Kubernetes on bare metal seems very appealing as well for performance reasons. But I want to tell you, in practice, it comes with several operational challenges, especially at scale. Now let's take a look from three different perspectives. I'll start with the cost efficiency. So bare metal often requires separate hardware environments, as we can see on the like the block on the left, basically for a different each use cases. So that increase the capex, scaling and the scaling can be really expensive as well. It's also require a lot of manual configurations. Compared to VCF, that's consolidated infrastructure into a single platform, so allowed you to run multiple clusters, Kubernetes clusters, without adding additional hardware. This is reduce both capex and operational complexity. The second is security. So for bare metal setup, it's typically like we share infrastructure across workloads that create the risk, required for different manual effort to enforce a data protection. But with VCF, we can run multiple isolated Kubernetes clusters with different versions using the vSphere namespace, and each with its own security policies and controls. Plus, data is equipped both at risk and in transit, which delivers enterprise-grade security by default. For the last one is the Kubernetes version flexibility. So on bare metal, we can see you're locked with one version. On this diagram is the 1.31. And this can be very disruptive. And VCF, we allowed you to run multiple Kubernetes versions simultaneously, with independent grades for different teams. This flexibility makes lifecycle management so much easier and far less risky. Now, this is one of my favorite part because we want to share some customer stories with you. First, let's take a look on this, our Notifer, which is emergency service. So they needed a high responsive platform that could handle both VMs and containers while scaling rapidly to meet some very unpredictable demand. So with the VCF, they've achieved a faster resource provisioning, automatic operation, and improved agility all on one single platform. And then the next one is the racial data. that's a provider of custom application development services. So they benefit from VCF unified management across VMs and containers too. Um, they built a very resilient infrastructure that support the secure operations across different geos. And most important, they also able to maintain the data sovereignty and meet the very strict compliance requirements. And the GCI, which is a data center modernization company in remote area in Alaska. So with VCF, they simplified operations in this remote area and enabling the team to deploy applications in days instead of in months. So even in these very hard to reach area locations in Alaska, which is really amazing, and we got so much good feedback from this customer. So what these stories tell us, basically, VCF is not just a one-size-fits-all solution. It's a flexible, powerful platform that can adapt to unique use cases, and also while delivering consistent benefits like simplified management, faster delivery, and secure scalability. These are all the key elements important to our customers. Okay, I've been talking a lot of good things about VCF. Now, you might have a question. Okay, you mentioned there are a bunch of challenges in the very beginning. What about the cost? All the challenges leads to high cost. How VCF would help our customers, help you to reduce the cost? Basically, we did an analysis, like we deliver up to 52% lower TCO compared to bare metal alternatives. Here is why. First is a comprehensive platform. So VCF, we deliver this integrated solution that bring together all the compute storage, networking, management, and then security all in one stack. So it's also included in our built-in Kubernetes runtime service, a global cluster management, self-service catalogs, all these with governance and cost control. So which eliminating the needs, the maximally to stitch together different third-party solutions on one platform. The second is we lower the cost through the lower capex and a higher efficiency. We have a report recently, which is done talk about like VCF, we enables like a higher VM density. This report I've already put in the resources. Feel free to take a look. We worked with principal technologies. So VCF basically deliver higher density and which means, customers, they will need less hardware cost for, this for the operation. And we also offer the policy-driven automation, right sizing with built-in tools. So customers, they also get better application performance and a lower storage cost through features like compression and disaggregated storage. The third part is a lower OpEx and a higher productivity. So this consistent management model is so important across these VMs and the container environment. That means the teams, they can basically leverage tools and skill sets. We minimize the cost for like retraining the team or hiring new talents. And the lifecycle management is also unified across our compute storage and networking. VM boot times are much lower. It's in minutes instead of you need like 20 plus minutes on bare metal. The last part is the security and the resilience. So VCF, we deliver a 6th level of isolation to protect against the cyber threats and failures, and which encrypts data end to end. We also include the capabilities such as like live patching, drift detection, and maintain this secure posture. So the platforms also, we worked hard to reduce the noisy neighbor issues with advanced load balancing. So altogether, VCF is not only reduced cost, it also simplified operations, improved the security, and delivered the performance and agility enterprises they need. So this is the resource page I mentioned. We have a bunch of assets. You can take a look. An announcement for the VKS 3.3 GA. Yeah, now I will hand over to Katrina for the demo. Thank you, everyone.
Yep. Hello, everyone. I hope you're doing well today. Thank you for joining us for our webcast today. So Audrey has set up the scene and talk about what we're actually doing with our platform and in VCF. And what I really want to do today is to give you a little bit of overview of what we're doing in the form of a demo. But think of this of showing you what we can actually accomplish with all of these things that we've been talking about. That will be this week, and then next week we will go deeper into the technical details of what we do with our platform. So I will just quickly start my demo, and I will guide you through that. So before I start the demo, I think what's important is to think about this whole idea holistically. So we've been talking about these supervisor services that are included in VCF. One of them being the vSphere Kubernetes service that allows you to deploy and manage Kubernetes clusters. But then we also have VM service that allows you to deploy and manage virtual machines in a slightly modernized way. But the main power of a platform like VCF is that we also include network service, so we can request things like load balancers on demand, and storage service, so we can request persistent volumes, for example, for our workload, but also the extensibility of the platform where we can add additional supervisor services into the platform to help us really provide everything we need for our workload. So to really show this in action, what I want to do in this demo is to deploy a 3-tier application. And this will consist of a database, which is running in a virtual machine, and also containerized backend and frontend of an application that will be deployed into a Kubernetes cluster. So the first thing we will do here is to deploy the virtual machine using VM service. So in our environment, we will start deploying the database VM. Now, I'm using the user interface just to keep this simple and to also show you what we can do easily. But all of these things could be, of course, done directly using CLIs or API directly, if that's something that you would prefer. So what do we need to do to deploy a virtual machine? Well, it's really simple. We will go and create a virtual machine. We will give our virtual machine a name. And then we will select the base image we want to use for this deployment. We will also go ahead and select a VM class to specify the level of resources that we want to assign to this virtual machine. So as you will notice here, we are deploying something you will consider a traditional workload, a virtual machine, but we're using a slightly modernized way to achieve this outcome. So instead of us doing everything manually, we're using the power that vSphere Supervisor offers to just declaratively define our desired state and letting the platform do all the hard work for us. So in here, for example, when I choose a VM class to assign to my virtual machine, all I'm saying is that I want to assign 2 CPUs and 4 GB of memory to my virtual machine. But now moving forward, we don't stop there. It's not just about deploying a virtual machine. What we're doing here is actually defining the end goal. This is how I want my virtual machine to look when the full configuration is finished. So part of that, what I can do is utilize those other services as I have mentioned. So for example, if I want to add any kind of additional storage for my virtual machines that will persist my data, I will create something that's called the persistent volume, and I can request it directly in this deployment flow. So I can go ahead and I can attach a volume. And again, all I'm saying here is I want to create a new volume with a capacity of certain size, and the storage service will go ahead and do that in the background for me. Similarly, I can use the network service to create load balancers on demand. So this is really useful because I'm trying to expose my database VM on certain ports. So in this scenario, what I will do is I will create a new load balancer and I will open it on 2 ports. So I'm saying that I want to add port 22 to be able to SSH onto my VM, but also because this will be a database VM for 3306 to open MySQL. And now we get to my favorite part of this configuration, and that's the actually bootstrapping of this virtual machine. So again, I'm not just creating a blank virtual machine, I'm doing a full configuration. So what we can do with VM service is that we can use Cloud Init to pass configuration to the virtual machine, and it will be applied during the first boot up of this machine. So what I will do here is I will paste in my configuration. And as you can see here, I can do things like configure users that I want to have on this database VM, but also go that step further. I can do the full database configuration as well. So what I'm doing here is I'm creating a user that will have access to my database. I'm also creating the database itself. I'm creating the tables in the database. And you will see that I'm also running a selection of commands to do the updates I would do on my virtual machine normally, but also install my SQL server and do the configuration of the database. So again, I'm just defining what I want to install on my virtual machine. And when I click next, what you will notice is something that Audrey has mentioned. We really try to make this as user-friendly as possible. So we try to create everything for you in the background. Having said that, it's always very useful to see what was actually requested and what was created, because not only will I be able to see all of those YAML manifests that have been automatically created for me, it will also help me to understand the structure. And most importantly, as we see all of the resources that we have requested in this flow have been created, all of those manifests, and I could also go ahead and download them here. And this will become really important when we get to the next part of the demo. So I can go through all of them. We can see our virtual machine, our secret, which is how we are passing configuration over to the virtual machine. And we can also see the load balancer configuration with the 2 ports and our persistent volume. I'll download all of these files, and then I can go ahead and deploy this virtual machine. After a while, we will see that the VM will be powered on and configured. It will have an IP address. And now we can move on to the second part of the application. So again, keep in mind we are deploying a single application that consists of both virtual machines and containers running on a Kubernetes cluster to provide the whole functionality. So to deploy the Kubernetes cluster, again, super simple. All I have to do is click next. I will give my cluster a name. I will select the version which I want to deploy. So you will also notice, as was mentioned, we are fully aligned with upstream Kubernetes. So you will be able to deploy Kubernetes version 132, which is provided as our vSphere Kubernetes release. So I will select the latest version because I want to for this demo. I will go next and I will configure my control plane of my Kubernetes cluster. So again, I'm selecting the number of replicas I want to have for this control plane. In this demo, I'm just selecting 1. I could do 3. I'm selecting a VM class to configure my control plane nodes again with resources that I want to assign. So I will select the particular site I want to assign. I can define a storage policy, which will basically tell it where to place the storage objects that it will create. So this is a link to my data store in the background. I can choose for my operating system, for my images. So when it comes to control plane, these are always Linux-based, and I can choose from Photon or Ubuntu. So this is something that we distribute. And then I can go ahead and configure my worker node pools. So as you can see, again, very simple. I can select the number of replicas I want to assign. I will do my sizing using VM class, and I can do the operating system, again, to choose what I want to use. For worker nodes, we also do have Windows support, so you could choose one of the three. And if you wanted to, again, you could also request additional persistent volumes for these nodes. So just as an example, I can add an extra capacity to my worker node. Now, there's much more you can do with the deployment of the Kubernetes clusters. This is a very simple setup. You can go beyond and do multiple worker node pools. You can do larger clusters, but all of that good stuff we will talk about next week. So it's a bit of a teaser. So for this demo, I just need a very simple cluster. So I'm doing this. I'm just going to click next and then proceed as soon as I. Okay, so what I can do now is, again, download the spec that it was created for me. So again, I don't have to know how to write this YAML file. It's all done nicely for me. And just click finish. And you will see that in a matter of a few minutes, we will have a cluster that's ready to be used. So in the user interface, I can go ahead and I can view the running configuration of this cluster. I can download the kubeconfig file to connect to it directly and some other operations. But for now, we'll just review this. And what we can do as well is look at all of those other objects that we have requested during the deployment. So for example, we can see all of the load balancer services that we have requested. So we will see a control plane for our Kubernetes cluster, but we will also see the service that we created for our virtual machine. We can also go look at the other things. For example, if we go into volume, we will see all of those persistent volumes that we have requested and created during these flows. And if we go to virtual machines, you will see multiples listed. So first of all, remember we would deploy the database VM, so that's our MySQL VM, but also because our Kubernetes clusters are deployed on virtual machines, you will see those listed as well. And if you want to, you can filter that out. So now we have our infrastructure layer set up. We can move on to deploying the actual containerized workload in that Kubernetes cluster. So this is just a nice view of things in inventory. So what I'm doing here, I'm going to log in to my Kubernetes cluster that I have just deployed, and I will just make sure that all my nodes are ready to be used. Now here's a spec for my application. Again, the application we are deploying is very simple, so we don't need to go into much of a detail. You will see that, for example, I'm here defining the connection to the database that we have deployed. So the way the application works is that the database is storing the data, the backend service that's running on Kubernetes is talking to the database, and then forwarding the information to a front-end service, which will also give us web access and UI, as you will see. The one thing I would like to highlight here as well is that we have used another service that we offer on vSphere Supervisor, and that's Harbor, that can be deployed to provide a container registry for your workload. This is something that you will most likely want to do just to make sure that all of your container images are stored in a secure location and you can do all the scanning and security things that you want to do. So as you can see, my container spec is pointing to a local version, Harbor. And then if we, again, start this, it can continue. I will also just quickly, here we can see this is my Harbor local Harbor instance. I have a project that's called 3-tier application, and I have those 2 container images in there. So that's what I'm pointing to. And if I look in my inventory, you will see that I have a vSphere namespace that's specifically created for this service. When we deploy supervisor services on our platform, we use something that we call vSphere pod. That's why we can see these listed in our inventory. But also for every service that we deploy, we create its own vSphere namespace to keep it all nice and separate. And again, we'll go into the technical details of how this works and why we do that, most importantly, next week. So if we now continue with our application, we've seen our spec, so I can just go ahead and apply this. And now I have deployed my backend. I can see that my pod is running. And because I requested a service for it, I can see that that's there as well. And my backend app has an external IP. I will now just go through the steps to do the same for the front end of the application. As I said, this will give us that web access. And now if I get the service, I can just grab this external IP and open it in my browser to access my application. This is very simple. I will going to register a user, and any user that I will register will basically be written in the database that we have created during the deployment of the VM. And any request that I will write will also be persisted in the database. So it's showing the communication from the web front end to the application backend, and then going to the virtual machine and reaching into the database as well. So that's our application. Very simple, 3-tier application. So in here, we have seen how we have used all of the services provided by supervisor to deploy this. So we've used VKS to deploy the Kubernetes cluster, VM service to deploy the VM, network service to do the load balancers, storage service to do persistent volumes, and also we deployed Harbor as our container registry. But that's not where the story ends, because it goes beyond this. We keep talking about this experience that we want to give you, where we give you a single platform and we give you a single API. And this is what you can achieve with it. But so far, we've just seen the deployment. But the main idea here is that what we have done is we have defined our application as code in our YAML manifests. And now we can take these manifests and we can store them somewhere else. So during the deployment, I was able to download my YAML manifest, and now I can upload them, for example, to a GitHub repository and use a tool to do continuous delivery of this for me. So one of my favorites and one of the industry standards is Argo CD. So let's have a quick look at how that would look like, just at a high level. I have a GitHub repository where I have defined my 3-tier application. I have done a certain structure that I like to do when I'm deploying applications with Argo CD. Again, we won't go into the details of the particular setup, but I have all of my files in this structure. In my Argo CD, I can create an application for my 3-tier app. So I will quickly do that and do some very basic configuration on how this should be done. The most important thing here is that I'm pointing my source to the GitHub repository I have created, and the path and the destination is the supervisor. And this is the really cool part, because this is really showing that power of targeting a single API, which is a declarative API. It's called vSphere Supervisor. So now I'm going to go ahead and create this app, and off it will go to deploy the part of the applications as we have gone through before. So I'm deploying, I have a parent application, deploying a Kubernetes cluster, a virtual machine, and once the Kubernetes cluster is deployed, also the application on top of it. And just to prove kind of all the components that this deploys, you can see exactly, if we clicked into the VM, you can see all those objects that we have gone through before. So we've created a PVC, we created a secret with Bootstrap, we created the actual virtual machine object, and also the service that is the load balancer. And once this is all deployed, including our application, which will start after we deploy our Kubernetes cluster, we will have a fully functional application with all of those components. So what we can do now is we can go back into our inventory. And as you can see, for the purposes of this demo, I have put this in a separate vSphere namespace just to separate the objects. You will see that what we have done here is we have deployed all of the same resources as before. So we can see our machines and volumes and services. And if we just grab the IP, we see again, we've deployed the same application, just a different, just a new version using Argo CD. And again, we can write a request and write it in the database, everything we've done before. But the idea again here is that not only have we defined everything as code, not only could we store it in something like GitHub repository, it's really opening up that world of GitOps patterns. So we can do things like continuous delivery, for example, like this. We can do continuous integration. We can do all of the native automation, but also opening the world to all of the tool sets of CNCF landscape that is out there and is available for us to utilize. So in my mind, that's the really exciting bit, because this is no longer just about deploying application once or defining infrastructure parts once, but it's do it once, do it in code, and use other tools to do the management and operations and automation and self-healing and all the good things that come with using something like Kubernetes and using the principles of declarative API and desired state management. So I hope that was of interest. I hope that you are a little bit intrigued. Again, if you would like to know more about all of the services that we provide, so how vSphere Supervisor actually works, what is a declarative API, and why do we talk about it in terms of Kubernetes, but then also looking specifically into the services like vSphere Kubernetes Service and its capabilities, VM Service and its capabilities, and some others, please join me next week. We will spend the whole session going through demos and a bit more technical details on how that works. So thank you very much for having me.
All right. Thanks, Katerina. Go ahead and turn your share off. Right on. Audrey, you want to come on up front? We got a couple minutes left. There was a couple of questions in the chat that I wanted to make sure that we had answered. But otherwise, fantastic stuff. Really appreciate the deep dive on that, Katerina, and a great overview, Audrey. I think it really helps set the stage because, like, back in the day, it was like, hey, Kubernetes is this thing. It's a completely separate world, like whatever. And now they're just workloads, right? Like a container. I mean, really, what is a container? It's a Linux process that's jailed inside of C groups, right? Windows, it's a similar process, but it runs on the Windows stack, needs a Windows host, VM in this case. But it's just another application. You're seeing more applications being sold as containers. You're seeing the way that you deploy things, even internal built applications. It's a pipeline that outputs a container, and then from that container, put it into another pipeline to actually deploy it and run it. So what a time to be alive, I remember doing all this stuff back in the day. We had to do it all manually on Linux hosts, and oh boy, it was not easy stuff. So it's incredible the amount of work that we've done here. So that being said, there was a question that a couple of questions that I don't know we're going to be able to answer. I think there was a question around FIPS and NIST. Roadmappy stuff, we can't really get into that. I don't know if there's a good canned answer for that just yet, but if there isn't one right now, I'll make sure that we've got one for the event. Katerina, I don't presume that you know anything about FIPS certification timelines.
We do have
if that's public knowledge yet.
We do have FIPS compliance, but we can provide the details.
Cool. Yeah, I remember we went through one of those compliance audits and certification achievements through vCloud Air when I was on the cloud team back in the day, and these things take years to do. So
we definitely do have it for VKS and the details. We do have documented it as well. So if you go have a look at our official documentation, there should be a section where we discuss specifically, but we can also gather these details and provide them.
Brilliant. So there was a question technically, how many namespaces can you have on one, I guess it doesn't really, it says vCenter, but I guess that probably doesn't apply anymore because we have worlds of distributed control planes, right?
Yeah, as an old consultant in me would say, it depends. But there's no real relationship. You can deploy multiple namespaces on a supervisor. I would just leave it on the supervisor level. The idea here is that it's really up to you, because you can think of a vSphere namespace as something that takes the Kubernetes concept of a namespace, which is all about maybe logical partition and assigning, resources and quotas and limits to a certain part of your environment, but we combine it with vSphere, and you can think of something like resource pools with extended capabilities. So when you take a vSphere namespace, it's a combination of, again, kind of logical separation where you assign your resources, but you also assign access policies. You define some basic configuration for VKS and VM service, such as content libraries that hold the images and things like that. And if you look at it from purely the access and separation perspective, it's really up to you how you define these. So you may want to decide that this is my test environment and I have one large namespace and everyone has access to it, and do what you want. Or you may think that that probably is not great, especially for production. So you can separate things per development stages. So this is my test staging production environment. You can also do it per team. So my team working on X has this namespace, other team has this. You can do it per application. That's really up to you. So that's why we don't really tell you how many namespaces you should have per supervisor, because it depends on your use case. There are some limits. These are defined in our configuration maximums, but I would
That's
just
good though, because it sounds like really it's all about the flexibility of choice. You have all these options and you're just building on the top of vSphere, which you already know, and you've already been able to pool out, carve out those resources. So whatever makes sense from a logical and from a resource grouping, it depends on the organization, your structure, and sort of the needs of the application, it sounds like, right?
Great.
Cool.
And I
So
think we have
we're
one
hitting
more
we're hitting the time.
question.
Audrey, what was that? Go ahead.
Sorry, I think there's one more question we can quickly answer. Do you need a separate appliance to enable Kubernetes? I think that's our vSphere Kubernetes service built in the vSphere that's provided the orchestration for VMs and the containers.
So just to slightly clarify or add to that, so what you don't need a special appliance. This is all integrated. That's our whole story. This is all in. At the moment, what you have to do is you have to enable vSphere Supervisor, which is a configuration setting you do within vSphere. Once you do this, it will deploy a supervisor control plane in form of small virtual machines that hold the control plane of this of supervisor. And also it will do a little bit of configuration on your ESXi nodes, such as basically allowing them to run these runtimes on them. So it's not an appliance, it's not a separate appliance, it's built in. At the moment, you just have to go and do a very basic configuration to enable it. And once you enable it, and this is maybe the important bit, you enable it once as the whole vSphere supervisor kind of landscape. As soon as you do, you get access to all of these supervisor services that you can go ahead and start using. So it's all there.
Sweet. Well, I think we're running out of time here. So I want to give Julianne a chance to come on back up, send us off here. I know there was a question in the chat here around eBPF. It's a very in-depth question. It's going to have a lot of technical answers. What I would say is join us next Tuesday, and we'll be able to get into that into more detail here. But we've run out of time, and so I just want to thank everybody for joining here. Julianne, send us off. Muted.
Thanks, Michael.
There you go.
Yeah, I think this is a really great session. It seems like there's a lot of excitement for part 2 in the chat. So I threw the registration in there again. We'll also send an email to everyone on here today with both the recording and the link for next week's session. So go ahead and join that. And then just as a reminder, as we close out this session, a survey will pop up, and we just love to have your feedback on that so we can share that with our speakers, as well as get some ideas for what you'd like to see next. So thanks everyone for coming today. Thanks for sticking on a few minutes later, and we will see you all next week.
Thank you, everyone.
Thanks.
Thank you.
Bye.